This lecture presents about the AVL trees, the double rotations. The double rotations, which includes LR rotation and as well as RL rotation. LR rotation, that is left is heavy, out of which the right subtree is heavy. RL rotation, that is RL rotation, right is heavy, out of which the left subtree is heavy. So if you concern about the single rotations so far which we have studied. So single rotation, that is LL rotation and as well as RR rotation. That is if the tree is right heavy, if the tree is right heavy upon addition or upon the deletion, then you need to perform the left rotation. And if the tree is left heavy, then you need to perform the right rotation. And coming to the double rotations. So within your double rotations, that is left is heavy, out of which the right subtree is heavy. Then you need to perform double rotation, that is LR rotation. Similarly, the other possibility, if the right tree is heavy, out of which the left subtree is heavy, then you need to perform RL rotation. So these are the scenarios of the single rotation and as well as the double rotations. So when to perform the single rotation and when to perform the double rotation has to be learned even before concerning about what kind of the rotation has to be performed. So when concerned about the LR rotation, left tree is heavy compared with the right tree. And within your left tree, right subtree is heavy. In such case, you need to perform the LR rotation. So within your LR rotation, there are certain assumptions which are being considered. That is, consider the grandparent denoted by GP, the parent denoted by P, child and left child, and C is stored as root. This scenario explains about LR rotation. And within your LR rotation, that is left tree is heavy, out of which the right subtree is heavy. In such cases, the scenarios is C becomes the root and P is the left child of C and GP is the right child of C. I'll give an example. And C's right tree is the GP's left tree. That is, if the C contains the right tree and this becomes the grandparent's left tree. And there may be also the possibility that is C's left tree, that is child's left tree may also be present. If the C contains the left tree, then it should be attached to the parent's right tree. Similarly, if you consider the RL rotation, when to perform the RL rotation, that is right is heavy, that is right tree is heavy, out of which the left subtree is heavy. In such scenarios, you need to perform the double rotation, that is RL rotation. Same notation, that is GP, PC and similarly LC, and there are certain modifications as compared with the LR. There is a certain difference in the LR rotation compared with the RL rotation. C is stored as root, unlike in the same case, that is LR rotation, C is stored as root. So here within the RL rotation, GP is the left child of C. So GP should be stored as the left child of C. And for C, the right child should be P, that is parent, previously the parent. And C's right tree, if it is present, then it should be attached to the P's left tree, that is parent's left tree. And C's left tree, if it is present, then it should be attached to the grandparent's right tree. These are the conditions, or these are the assumptions which are being made to perform the LR rotation or to perform the RL rotations. So when does this LR rotation has to be performed? That is, left tree is heavy, in which the right subtree is heavy. Then you need to perform the LR rotation. So here within your LR rotation, as I've explained, before rotation, the grandparent, parent, I'll explain with an example of what is this grandparent, parent, child, left child or right child and so on. So consider this is a grandparent and this is a parent and this is the child, and to this it may have the left child and the right child. So here the new node is to be inserted as the left child, or it can be inserted towards to the right child. Then in such cases, consider the left child is to be inserted to the left of the C. Then it is an unbalanced state. You have to perform certain rotation, that is double rotation. So similarly, if you consider this kind of here, this scenario, the right child is being placed as to the right of the child C. These are the notations which are being described in your LR rotation. That is, what does the grandparent becomes, what is his parent, how does it looks like, I mean in which scenario it looks like the child, and similarly LC and as well as the RC, that is right child. So this is the before rotation and the after rotation. Of course this is also the before rotation, because in either of this scenario C becomes the root. These are the possibilities of where for the child either it may be the left child may be present or it may be the right child may be present. So here when you consider about your the LR rotations, that is as I mentioned, that is grandparent and similarly parent and as well as the child, and to this child the left child may be present. And after rotation, that is in the LR rotation, that is after rotation, C becomes the root, the same thing that I have explained in the previous part, that is in your previous slide. C becomes the root node, and similarly P is the left child of C and GP is the right child of C. C's right tree, if it is present, it becomes the GP's left tree, and C's left tree, if it is present, then it becomes the P's right tree. What does these statements indicates? That is here as I mentioned, that is grandparent. If you look at this kind of here the tree, that is grandparent and similarly parent, child, left child is present. That is before the rotation. And after the rotation, how did I explain? That is C is stored as root. So this kind of here the C is being stored as the root. And P is the left child of C. That is P, this is the parent P. This is being stored as left child of the C. And what does your next statement says? GP is the right child of C. So GP, that is this kind of here the node, is being stored as the right child of C. And what does the next statement says? C's right tree if it is present. But according to this tree diagram, we have the left child. So C's left tree is to be connected to the P's right tree. So this LC has to be connected as the right child for C, I mean P, that is a parent. This is what the before rotation and after rotation is being involved. This is before rotation and the after rotation. So consider particular the same scenario, that is left rotation, grandparent, parent and similar child, because I've taken two scenarios. For child, it may be the left child, you are adding the new node, or right child, you may be adding the new node. So upon adding the right child, that is C becomes a root, the same thing which I have explained, and P is the left child, and GP is the right child of C, and to the next one, C is right tree if it is present. Then you have to attach this right tree of C to the GP's left tree. So GP's left tree, it is being attached. This is what you need to understand about how to perform the double rotation related to LR rotations. This becomes the before rotation and this is your after rotations. Now based upon the explanation that I have given related to the LR rotation, that is double rotation, we shall construct the AVL tree with the possible case, with the keys, that is 30, 9, 38, 6, 11, and later on insert the node 10. Then, so first node, that is 30, which becomes the root node, the balance factor will be equal to 0. And consider the next node, that is node 9. Node 9, where it has to be placed? It has to be placed towards to the left of node 30. And node 9 is being inserted to the left of node 30. 38, it starts comparing with the root node, traverses towards to the right, and then places. That is 38 node is being placed to the right of the node 30. And take the next node, that is 6. 6 starts comparing with the root node, traverses towards to the left, and the current node is 9 and traverses towards to the left, and the node 6 is being placed. And goes for the next node, that is node 11. Starts comparing with the root node, that is 30. The value that you want to place, add, is lesser. So traverses towards to the left. And the current node is node 9. And what is the node that you want to insert? That is 11. And that is how it is being placed towards to the right of the node 9. Take the next node, that is 10. So searches from the root node, traverses from the root node, compares. So 10 is less. So you have to traverse towards to the left subtree. And similarly, checks the current node's value, that is 9. And what is node that you want to insert? That is 10. Traverses towards to the right. And what is the current node? That is node 11. And what is the node that you want to insert? That is 10. And then it is being placed as the left of the node 11. So node 10 is being placed as the left child of node 11. Observe this scenario. How does this, calculate the balance factor, because the balance factor you need to find at every inserting of the node. So for upon inserting till node 11, no deviations in the balance factor. But by adding the node 10 to the existing tree, it is an unbalanced. How can we say it is an unbalanced? That is node 10, the balance factor is equal to 0. Node 6, the balance factor equal to 0. Node 38, the balance factor equal to 0. And node 11, the balance factor equal to height of your the left subtree, that is 1, minus height of your the right subtree, that is equal to 0. So 1 minus 0, that will be equal to 1. And height of your the left subtree for node 9, that is 1, minus height of your the right subtree, that is 2. So 1 minus 2, that will be equal to minus 1. And also you have to find the balance factor of the node 30. So node 30 balance factor, that is height of your the left subtree, which is equal to 3, because node 9, node 11, node 10 is present. So height of your the left subtree is 3, and height of your the right subtree is equal to 1. So 3 minus 1, that is equal to 2. So node 30, it has been affected because the balance factor is equal to 2. And check from the perspective, that is from node 30 perspective. So left is heavy. That is what we can say by observing this kind of the tree diagram. We can say left is heavy. And if you recall about the concept of when to perform the double rotation, when to perform the single rotation, the part of the pseudocode, you can observe. First thing is check whether if left is heavy, and out of which if the right is heavy. What does this mean? So here you can observe left is heavy. So if you observe this part of the tree, it is left is heavy, and out of which the right subtree is heavy. The right subtree is heavy, and that is how we can say what kind of the rotation has to be performed. That is left is heavy, and out of which the right subtree is heavy. So what did I say about the LR rotation? That is left is heavy, and out of which the right subtree is heavy. Then in such cases, you have to perform the LR rotation. And I've already explained, when you are performing the LR rotations, that is the grandparent, parent, child, left child, and what becomes the root node, what has to be attached to the root node, what has to be attached to the right of the root node, and so on. That is GP, that is a grandparent, P becomes the parent, child, left child and similarly right child. So here, if you look at from the perspective of the root node, that is 30, the node which has been affected. So here you need to perform the LR rotation. So GP, P and similarly C, and according to this kind of the example, that is node 10 is being attached to the left of node 11. So how does this tree looks like? The same thing, that is GP, that is node 30, P, that is node 9, and C, that is node 11, and 10, that is left child. And after rotating, that is after you perform the LR rotation, what becomes the root node? Root node becomes C. To the left, that is parent. To the right, that is grandparent. And if there is any left subtree that is present for the child, then it has to be attached to the parent's right tree. That is what we have learned so far. What will be the modifications after performing the LR rotations? So based upon this one, that is what becomes the child, I mean the root node after rotation, that is C. What is this C indicates? According to this kind of this is the GP, this is P, that is node 9 is P, and here C becomes the node 11 and LC becomes node 10. So as I've explained, what becomes the root node? That is C becomes the root node. C becomes the root node. So 11 is been placed. And the next one, that is P is being stored as to the left child of C. What is this P? That is 9. So 9 is being stored as the left child of C. Similarly, that is GP is stored to the right of C. And LC, if it is been present, it has to be placed to the P's right subtree. That is how the node 10 is being placed. And the remaining part of the tree remains the same thing. That is node 6 is being attached to the node 9 as a left child. And similarly, the node 38, since already for node 30, 38 is the right child. So 38 is being placed as the right child of the node 30. And that is how we have inserted the node 10, and they have performed certain kind of the modifications, that is LR rotations is been involved. And at the last, you should also check the balance factor of each kind of the node. So by looking at itself, or calculate the balance factor of every kind of the node in the final tree, where there will not be any kind of the modifications. That is, it is within the allowable range. And now consider the 39, 38, 6, 11, and then you have to insert the node 12. So 30 is been inserted as a root node, and 9, that is a left child, 38 as a right child, 6 as a left child of the node 9, and 11 as the right child of the node 9. And when you are inserting, find the balance factor. At every stage, whenever you are adding or whenever you are deleting the node from the existing tree, you have to find the balance factor of every kind of the node. If there is any deviation, perform accordingly, whether it is a single rotation or whether it is a double rotation. So far, until adding the node 11, there is no deviation, because calculate the balance factor of every node in this given tree, we can say there is no deviation. And whenever you need to insert the node 12, so node 12, where it has been inserted, that is, it searches from the root, traverses towards to the left and traverses towards to the right, and the node is being placed to the right of the node 11. So node 12 is being placed as the right child of the node 11. And find the balance factor. So when you find the balance factor, that is, it is 0, node 12 is 0, node 6 will be equal to 0, node 11 it will be equal to that is 0 minus 1, that will be equal to minus 1, node 38 it will be equal to 0, node 9 1 minus 2, that will be equal to minus 1. And when you calculate the balance factor of the node 30, that is height of the left subtree, that is 3, minus height of the right subtree, that is 1. So 3 minus 1, that will be equal to 2. So find the affected node, because here node 30 is the affected node. Look from that perspective. From that perspective is left is heavy, that is left tree is heavy, out of which the right subtree is heavy, then in such cases, what kind of further rotation has to be performed? When it is left heavy and out of which the right is heavy, then you need to perform the LR rotation. So left to right rotation has to be performed. And when I say the LR rotation, the property remains the same thing. That is, consider the scenario grandparent, parent, child, and similarly right child. And after a rotation, C becomes the root, P becomes the left child, GP becomes the right child, and RC, if it is present, any subtree has been present, then it has been connected to the GP. So based upon this one, you are familiar about what is this GP. So this becomes your GP with the node 30, and this is a parent, that is 9 with the node 9, and this is C, that is child with the value node 11, and this is the RC with the value to be equal to 12. So based upon this, the scenario, so child, what is the child? That is 11. So 11 becomes the root, not the entire final tree root between this one. So 11 is becomes the root node. Of course, 11 becomes the root node, and similarly the remaining part is unchanged. That is here, if you observe the parent is 9. 9 is being placed to the left of the child, this scenario, and grandparent, that is with the node 30, this is being placed as the right child, and similarly the remaining part, that is 38, is placed as it is the right child of the node 30, and node 12, that is RC, is being placed as the left child of the grandparent. So node 12 is being placed to the left of the node 30. This is how we can transform. We can convert the unbalanced tree to the balanced tree. That is what an example related to self-balancing tree. Because if you recall the concept of the AVL tree, so AVL tree, it is also similar to the binary search tree. All the properties that are being present within your binary search tree remains the same. And along with, we can also say it is a self-balancing tree. That is, at any case, by adding the new node or by deleting the an existing node, then this unbalanced tree can be converted into the balanced tree by performing the rotations. The rotations which involves, that is LL rotation, that is single rotation, and the double rotations, that is LR rotation, and as well as the RL rotations. Now consider another example where you need to insert the nodes with the values, that is 60, 50, 80, 40, and so on. So take the first node, that is 60, it has been inserted as the root node according to this scenario. The next node, that is 50, is been inserted to the left of the node 60. 80, which has been inserted to the right of the node 60. 40, it starts comparing from the root node 60. The node that you want to insert is 40, so traverses towards to the left tree. And 50 compares with the node that has to be inserted, that is 40, and then node 40 is being placed as the left child of node 50. And the next node, that is 52, is being placed, 70 is being placed, and similarly 90 is being placed. Of course, the 52 has to be placed first, and then 70, 90 is being placed accordingly. Node 30, that is every stage, like at every step, whenever you are inserting the new node or whenever you are deleting the new node, deleting the existing node, then you have to check the balance factor. So far there is no deviation in the balance factor. And add node 30, that is no deviation in the balance factor. Add node 42, no deviation in the balance factor. Similarly, 51 is been inserted, 54 is been inserted. And when you are adding the node 56, so when you are adding the node 56, the balance factor has to be found. Of course, at every inserting the node, the balance factor has to be found. So the balance factor of 56 is 0, and so on. You will be computing the balance factor of these kinds of the values. And when you are calculating this balance factor of the node 60, the balance factor is equal to 2. And what is the node that has been affected? The node that has been affected is 30. It is equal to 60. One correction. That is, affected node is equal to 60. And look from this perspective, that is node 60. Which one is heavy? We can say like your left tree is heavy. So left tree is heavy, and out of which the right subtree is heavy. The right subtree is heavy. Then in such cases, you have to perform LR rotation. So within the case of your the LR rotation, we have indicated like C is the root, P is the left child of C, GP is the right child of C, and so on. So what is the node that becomes your, the affected node? The affected node that will be equal to, that is node 60. So here C, this is your GP, P, C. So C becomes the root node, that is 52 is the root node, and to the left, that is P is to be stored, that is node 50, and to the right, that is GP, that is 60 is being stored. And whatever the nodes that are being present towards to the node 50 remains the same thing, that is 40. And if you recall about the concept of your the C's right tree, if it is present, C's right tree. So if you start with this statement, C's right tree is placed as the GP's left tree. So C's right tree, that is 54 and similarly 56. So 54 and 56 is being placed as this kind of your the GP's left tree. That is 54 and similarly 56 is being placed. And coming to the C's left tree, that is node 52's left tree, that is 51, has to be placed towards to the attached towards to the P's right tree. What is this P? That is 50. So node 50, we are attaching the left tree of your the C. That is 51 is being placed to the right of the node 50, and find the balance factor. The remaining nodes remains the same thing, because those are unaffected nodes. That is node 60's right tree remains the same thing. That is 80, 70, 90 will be the right subtree of your the node 60. And consider another example, that is node 4 is been inserted, node 2 is been inserted to the left of the node 4, node 10 inserted towards to the right, and checks the balance factor, no deviation. Node 7 is inserted towards to the left of the node 10, checks the balance factor, no deviation, and adds the next node, that is 1 is been added towards to the left of the node 2, no deviation. And similarly node 11 is been inserted, and similarly the next node, that is 7 is been, here in the, if you look at this kind of the example, that is node 4, 2, 1, and similarly 10, 7, 11 are being inserted. To the next scenario, that is you need to insert node 3. Node 3 is been inserted to the right of the node 2, and checks the balance factor, no deviation. And node 6 has been inserted to the left of the node 7, no deviation in the balance factor. And the next scenario, that is you have to insert the node 12. So where actually the node node 9. So where actually the 9 is to be placed towards to the right of the node 7. And upon the next one, that is here, this is what we have observed. Upon inserting the node 8 to the existing tree, the balance factor of the node 4 is being affected. The balance factor of the node 4 is equal to -2. And this is the node that has been affected. So start from that perspective. If you look at from the node 4, we can say right is heavy. Right is heavy, and within which the left subtree is heavy. So when right is heavy, and out of which the left is heavy, then you need to perform RL rotation. So if you recall about the node that has been affected is 4, and you need to perform the RL rotation. And within the RL rotation, I've explained about before rotation and similarly after rotation. So the values of your the C, GP, and so on is being considered. Within this case, we can say C is the root. That is, this is the GP. Start from the node that has been affected. This is GP, this is P, and here this is C, and this is your right subtree and the left subtree of your C. So here, based upon these values, we can say after rotation, C is being stored as root, GP is being stored as the left child, P is being stored as the right child of the root node, and C's right tree is attached to the P's left tree, and C's left tree is being placed as GP's right tree. So here after rotation, that is, as I mentioned, C becomes the root, that is 7 becomes the root, and perform the necessary changes as per the statements which are being given. That is, GP is the left child of C, and P is the right child of C, and as well as C's right tree is placed as the P's left tree, and C's left tree is placed as the GP's right tree. And find the balance factor at every stage. This is your final tree, and find the balance factor, or it satisfies because it is within the range of the values of the balance factor. After calculating the balance factor, it will be either 0 or 1 or -1. So this is the AVL tree. So far what we have learned is, we have covered about the single rotations and as well as the double rotations. Within the case of the single rotation, that is LL rotations, and similarly RR rotation. That is, when the tree is right heavy, perform, that is, rotate left. And when the tree is left heavy, then rotate right. Similarly, when the left tree is heavy, and out of which right is heavy, right subtree is heavy, then in such cases you have to perform LR rotation. And when the right tree is heavy, out of which the left subtree is heavy, then in such cases you have to perform the RL rotations. And I've already explained what node becomes the root node, what should be attached to the root node as a left child, what should be attached to the right child of the root node, and what happens when there is a subtree that is present for your C, and when there is a right subtree that is present for your C, and how it has to be attached depending upon whether you are performing the LR rotation or whether you are performing the RL rotations. In the same fashion, you can also observe, that is, these are the after rotations, after inserting the nodes. So far, no deviations. And whenever you are inserting the node 15, then the balance factor of the nodes is being affected. So what is the node that is being affected? That is node 9, because the balance factor of the node 9 is equal to height of the left subtree, that is 0 minus 2. So what kind of the rotations has to be performed? So the rotation that you can observe, that is, tree is right heavy. If you look at from the node perspective, that is from the node 9's perspective. So if you look at from this perspective, right is heavy, and out of which the left subtree is heavy. Then you need to perform the RL rotations. So based upon your RL rotation, that is, this becomes the GP, and this becomes the P, and this becomes the C. That is, this is your GP, and similarly this is P, and this is the child. So between these, the parent, the root becomes 15, and to the left, that is, GP is being attached, that is node 9, and whereas to the right, that is, P is being attached, that is node 16. And whereas the remaining portion of the tree remains the same thing. That is what you can observe from this kind of the diagram. The remaining portion of the tree remains the same thing. So start looking from the node that has been affected. From that perspective, you have to do according to the modifications, whether it is an LL rotation or whether it is an RL rotations.